Lesson 2.5, Video 1, Graphing Linear Inequalities. So a couple thoughts here to focus on, that we are graphing lines, so the linear part, and inequalities refer to symbols that we've seen in the past, a less than symbol, a greater than symbol, a less than or equal to, and a greater than or equal to. Now in the past we've used these symbols, but they have usually been on a number line. So for example, if I wanted to graph x is less than 2, I would find 2 on a number line. Since it's less than without a line underneath it, as opposed to less than or equal to, I would put a circle instead of a solid dot, and I would go less than, so I would point left. That's a typical inequality that we have dealt with in the past. If it was so basically, if we were to zoom in on these choices, a less than symbol is a circle, a greater than symbol is a circle, but when you put the line underneath it, then it becomes a filled in dot. So it's including that point as opposed to not including it. So how does that transfer to lines? Well, with lines, again I'll zoom in here, with lines, a less than or greater than symbol without a line underneath it are dotted. So you'd graph a line that is dotted and not a solid line. For the inequalities of less than or equal to or greater than or equal to, just like this part right here has it's a solid line, your line would be solid. So with inequalities with graphing linears or lines, you have dotted lines for less than or greater than, solid line for less than or equal to, and greater than or equal to. Alright, so the nice thing about graphing these types of situations is that you're still graphing lines, which you've become hopefully quite good at, and I've noticed that you have. You would naturally start with putting it into slope-intercept form. In slope-intercept form, y equals mx plus b. Now there's 3 parts to graphing an inequality, unlike just graphing a line. If we graph a line, we would use our y-intercept to find one point, use our slope to find the next, connect the dots, we're done. But with graphing linear inequalities, our first step is to graph or put it in slope-intercept form. The second one is to decide if it's going to be solid or dotted before you graph it on your paper. And as mentioned, we have solid lines when they are equal to's, so less than or equal to or greater than or equal to. And we have dashed or dotted, is what I call them, when we just have less than or greater than. So we put it in slope-intercept form for step 1. We decide if it's going to be solid or dotted. And then our last step is to decide where we shade. Now as mentioned up here, we had to decide which way our arrow was going to go. Does it go to the left or to the right? With linear inequalities, it's a similar decision that we have to make, but really what's happening is when we graph our line, let's say for example I graph a dotted line right there. I have essentially created a railroad track, and we're going to shade one side of that railroad track or the other. Just like we had to point an arrow left to right with an inequality, we have to decide what side of our tracks do we shade, because any point that's shaded would be considered a solution. So we put in slope-intercept form, we had it properly dotted or solid. In this case I drew a dotted line. Now we have to decide shading on one side or the other, and I usually describe it as up or down. So if you have a greater than symbol, you would shade above. If you have a less than symbol, whether it's a solid or dotted line or less than or equal to or just less than, it is shaded below. That's one way to do it. Another way to do it is with a test point, and that's usually 0, 0. If your line doesn't go through it, you can use that. And you plug it in. If you get a true statement, you would shade that side that that point is on. So in this case, if I got a true statement by plugging in 0, 0, I would shade down here, because that's where the point 0, 0 is. If I got a false statement, I would shade on the other. And this is the beginning of graphing linear inequalities. So the end of lesson 2.5, video 1.